Hi, this is our SNAP project proposal.
I'm Andrew.
I'm Ben.
I'm Milan.
I'm Natalie.
And I'm Nathan.
So we've got three main things we're going to go through. First is our data set, why we chose it, some of the questions we have about that data set, and then what kind of insights we want to get from what we looked at. So we decided to go with the Venmo transactions data set because not only did we think there could be some interesting findings in it, but it was also pre-cleaned and there's lots of different transactions, 7 million of them. It'll be easy to access because there's no API key required.
Yeah, and so one key impact that the data set can have is, first of all, we need to download it. And so the way that we do that is we install MongoDB, which is what the data set is kind of based upon. And then we will download the data in tar form and we will uncompress it. And so we'll be downloading it at a 1 gigabyte size, and we'll bump it up all the way to 10 gigabytes when it's uncompressed. And this will allow us to have access to those roughly 7 million transactions in the database. And the way that it's formed, so the actors are Venmo users, and then the edges are transactions between users. And these edges have two main properties. First of all, they're directed. That's to say that when actor A sends a transaction to actor B, there's a directionality associated with that because one actor is sending and one actor is receiving. And additionally, there's also a weight to each edge. So that means that each transaction is associated with a certain dollar amount. So conceptually, these edges are weighted, but within the data set, we don't actually have access to the dollar amounts. So that is something that we won't actually be able to use. And then finally, there's some other miscellaneous information like the type of transaction, the notes about the transaction, friend count, and then the status, along with lots of other aspects that we can use for our data analysis.
Yeah, so we're coming in with a host of questions that we want to explore and answer about the network. We're coming in with the assumption that most people who are using Venmo already have a connection with somebody in real life, and that's why they're sending money to that person. So we want to explore the motivations behind these transactions and try and identify trends and subgroups within the network. So going off of this, we want to see, whether transactions are for business purposes or social purposes, what factors have influence on new edge creation. Someone sending someone money for the first time, and then just trends that we can find within the network that can let us predict future transactions. There are many recurring transactions. We'll talk about this later, but many people use Venmo to pay rent. And so we want to see if these kind of recurring transactions and connections between people can be used to find insights about the network. And then lastly, we also want to find some metrics about the network, such as the density and the centrality of users.
Our next question focuses more on the broader social implications of our network analysis. We propose the question, can we use in-degree centrality to predict the relative wealth of an actor within this network? And we predict that the actors who appear to be wealthier will have a higher in-degree centrality due to different social practices and assumptions surrounding money. And to potentially answer these questions, we're going to filter the data for a metric such as rent, which can be used as a proxy for determining socioeconomic status. We can then use this metric to establish a spectrum of relative wealth, potentially calculating Z-scores to standardize each actor's position within that spectrum. And then using this data, we can fit a regression model to see if there is significant association between in-degree centrality and relative wealth along these parameters. The only problem with this question is that there are a lot of limitations to the generalizability of any potential analysis, just because it's going to be really hard to control for a bunch of potential confounding variables, but looking at the trends that we might find may still allow for interesting insight onto like the social aspects of the network. And so for our visualization methods, we will first look at component graphs, focusing more on the larger components and the underlying data for analysis. We also plan to visualize a K-core decomposition subgraph, using this to visualize metrics of network cohesion. For example, are there many groups of highly connected and active individuals, and do any definitive clicks form?
We're also going to look into a bunch of different metrics for our social network. And we split them up into global network attributes and local network attributes. So starting with the global, we're first going to look at network density, just to kind of figure out how likely it is that certain transactions are interconnected with each other. We're also going to look at clustering coefficients, and this will be helpful for determining subgroups of people and users that are often Venmoing each other. So for example, this could be a group of friends that go out frequently and split Ubers or dinners and whatnot. And then lastly, we want to look at the assortativity coefficient. And this is helpful again for determining similar groups of Venmo users, whether it be through the frequency that they actually use the app for transactions, or whether they have similar attributes. Moving on to the local network attributes, we want to first look at the degree centrality. So this determines and kind of separates and distinguishes users who use the app to make payments or to receive payments. So as an example, landlords would probably have high in-degree centrality since people are often paying them, whereas tenants would have high out-degree centrality because they're paying their landlords. We also want to look at betweenness centrality, which could potentially show the path of money between users. And so an example could be gambling transactions. If there's a middleman who actually receives and pays the same amounts of money to other people. We also want to look at closeness centrality and eigenvector centralities, which are useful for showing, again, how interconnected Venmo users are with each other, and figuring out whether groups of Venmo users use Venmo a lot. Lastly, for methods, we're going to do some graph models and regression analytics. So we want to use an exponential random graph model to predict how these transactions emerge and how patterns within the transactions emerge. And then again, we want to use regression, as Milan was saying, to kind of figure out that broader wealth question and see if we can predict anything there.
So in terms of the roles that each group member will be taking, Ben and Natalie are both coming in with more of a coding background. So they'll be the ones who will be primarily handling the data, extracting the data and visualizing the network. Andrew and myself will be analyzing the network for the metrics that Andrew talked about, both the global and local metrics that we were looking for. And then Milan and Andrew will be the ones primarily presenting the insights and takeaways that we find in the network. And Milan and myself will be the two who are contributing the most to the final report that we will turn at the end of the project. Thank you.